phone to satellite. We've been trained to think that no bars means no connection, but that reality is fundamentally changing. Currently available smartphones now have the built-in capability to bypass traditional cell networks and communicate directly with satellites in low Earth orbit. This isn't a futuristic prototype. It's a deployed technology, and today we're going to break down exactly how it works. The physics of connection. Before we get to the user features, it's essential to understand the fundamental science that makes this possible. The choice of orbit, the way the signal travels, and the challenges that engineers had to overcome are key to appreciating how this works. It all starts with the unique environment of low Earth orbit. Why is low Earth orbit the only viable option for a standard smartphone to make a connection? The choice for LEO is a matter of simple physics and energy conservation. A phone's transmitter is like a small flashlight. It can easily illuminate a nearby object, which represents a LEO satellite just a few hundred kilometers away. Trying to reach a GEO satellite at 35,000 kilometers is like trying to use that same flashlight to illuminate a skyscraper in another city. The beam just doesn't have the energy to get there. What are the primary engineering hurdles, like the Doppler effect, that had to be solved? The biggest engineering hurdle is managing the extreme Doppler effect. Because the satellite is moving at over 28,000 kilometers per hour, the radio frequency shifts dramatically, like the changing pitch of a passing race car. The phone's modem must perform constant, real-time calculations to compensate for this shift and maintain a stable link. How does a constellation of satellites provide continuous coverage if each one is only in view for minutes? A single LEO satellite is only in view for a few minutes. So continuous coverage is achieved by using a large constellation of them working in concert. Think of it as a massive, highly coordinated relay race in the sky. Before one satellite disappears over the horizon, the network seamlessly hands off your connection to the next one coming into view, ensuring your link is never dropped. The hardware-software bridge. Now let's look at the incredible technology inside the phone itself. The fact that a standard, off-the-shelf smartphone can perform this direct-to-satellite link is a marvel of microengineering. This hardware and software bridge is what puts this capability into the hands of millions. What is the core hardware innovation inside the phone that acts as the bridge to the satellite? The core hardware innovation is the integration of a compact, high-efficiency, phased array antenna. Instead of a single moving part, but a grid of tiny antennas that work together, using minute timing shifts in their signals to form and electronically steer a focused beam of energy. It's a solid-state solution that allows a small, flat device to aim a signal with incredible precision. How does the phone's software pinpoint a satellite it cannot see? The phone's software acts like an astronomer calculating an eclipse. It uses a preloaded ephemeris data file, which is a precise schedule of every satellite's orbit, combined with its own GPS location. It doesn't need to see the satellite. It calculates the exact aiming point and directs its transmission there, knowing the satellite will be in position to receive it. What is the structure of the data packet that gets sent? The data packet is a model of efficiency, structured like a condensed accident report. It contains only the most critical telemetry: your precise GPS coordinates, a timestamp, your phone's current battery level, and a simple code corresponding to the nature of your emergency. Every single byte is optimized to convey the maximum amount of vital information with the minimum amount of energy. How does the phone know its message has been received and not just lost in space? It is a confirmed handshake, not a message sent into the void. The communication protocol requires the phone to listen for a specific confirmation ping from the satellite after sending its initial message. This confirmation is a critical part of the user experience, as it provides absolute certainty that the call for help has been successfully received. From theory to hand. Now, let's move from the physics to the products themselves. Different manufacturers have taken this core technology and built unique, practical features around it. How a user interacts with this service and what they can do with it varies significantly between ecosystems. How does Apple's emergency SOS feature guide a user through the process in a real-world emergency? Apple's emergency SOS feature is designed for simplicity under duress, acting as a digital co-pilot. The user interface presents simple, multiple-choice questions to quickly assess the situation and then displays an on-screen graphic that physically guides you to point your phone directly at the satellite. This removes the guesswork from a high-stress situation, making it incredibly practical to use. What is the practical advantage of the two-way messaging found on Garmin's InReach devices? The practical advantage of two-way messaging is the difference between hope and certainty. Sending a one-way SOS is like launching a flare and hoping someone sees it. With a system like Garmin's, you get a message back from the rescue team, allowing you to confirm details, understand that help is on the way, and make better decisions while you wait. How has Huawei expanded the use case beyond just emergencies on its network? Huawei has broadened the use case by allowing general, non-emergency communication. Their system allows for sending and receiving standard text messages and even highly compressed images when you're off-grid. This transforms the feature from a pure emergency tool into a limited but useful off-grid communication service. The user's toolkit. Beyond life or death emergencies, this technology offers very real, practical applications for everyday peace of mind. It's a toolkit that allows for a new kind of remote communication and safety. Let's talk about what you, the user, can actually do with it. Beyond a life-threatening emergency, how can a hiker use this technology for peace of mind? A hiker on a multi-day trip, far from any cell service, can use a feature like Apple's Find My Phone via satellite. Once a day, they can manually send their location to their family, which appears on a map. This provides immense peace of mind for loved ones without requiring a full emergency declaration or even a text message. What are the absolute must-know limitations for anyone planning to rely on this technology? The most critical limitation is the need for a direct, unobstructed line of sight to the sky. Much like a solar panel needs direct sunlight to generate power, the phone's small antenna needs a clear view to send and receive these faint signals. Trees, canyons, or even a backpack can block the connection, a fact users must understand before relying on it. Can you walk us through the exact steps a user with a compatible iPhone would take to activate the SOS feature? To activate the SOS feature on a compatible iPhone, you first attempt to call an emergency number like 911. If no cellular network is available, an SOS icon will appear, which you can tap to connect to a satellite. The phone will then guide you to point it at the sky and present a short questionnaire to send to rescuers. Future of connectivity. The current features are just the beginning. The ultimate goal for many is universal connectivity. The next wave of innovation is focused on making this technology a standard, invisible part of all mobile communication. This involves new standards and even more ambitious satellite networks. How does Starlink's direct-to-cell model aim to make this technology universal? Starlink's direct-to-cell model is designed to be universal by putting the complexity in space, not in your hand. Their satellites are equipped to broadcast standard 4G protocols, effectively acting as a cell tower in orbit. This means unmodified smartphones can connect to it without needing any special hardware or software. What is Samsung's vision for integrating satellite communication directly into the 5G standard? Samsung's vision is to make the switch between networks seamless and automatic. By fully integrating satellite links into the 5G standard, the phone itself would be smart enough to detect when you lose terrestrial signal and automatically switch to a satellite connection. The user wouldn't have to do anything. Their phone would simply stay connected. What does a future of ubiquitous, low bandwidth connectivity mean for society? The ultimate societal impact isn't about getting high speed internet in the mountains. It's about establishing a foundational global safety net, a baseline of low bandwidth connectivity that ensures no person is ever completely unreachable in a time of crisis. This fundamentally changes the definition of personal safety in the modern world.